Do something for me right now. Turn one hand palm up. Now touch the tip of your thumb to the tip of your little finger, pinch them together, and gently bend your wrist towards you. Look at the inside of your wrist. Some of you just watched a thin cord jump up under the skin, running straight down the middle. Some of you see two, and some of you are staring at a flat, smooth wrist with nothing there at all. That cord is the tendon of a muscle called the palmaris longus. It runs from the inside of your elbow down to the flat of your palm. And here's the strange part. Whether you have it or not is essentially a coin flip written into your species. Depending on where your ancestors came from, somewhere between roughly 1 in 20 and 2 in 3 people are simply born without it in one arm or in both. Now think about what that means. This is a muscle that a huge fraction of humans walk around their entire lives completely missing, and they never notice because losing it costs you nothing at all. Let's be precise about what this muscle actually is, because that's where it gets strange. The palmaris longus is a long, thin, spindly muscle in your forearm. It starts up near the inside of your elbow on a bump of bone called the medial epicondyle, narrows into a slender tendon partway down, and anchors into a broad sheet of tough tissue in the middle of your palm. Its tendon is the one you can see. And the reason you can see it so easily is itself a clue. Most of the tendons that bend your wrist and fingers are tucked deep, held down under a thick strap of tissue at the wrist. The palmaris longus tendon isn't. It rides right over the top, closer to the surface than almost anything else in there. It's the most superficial tendon at the front of your wrist. So the test is simple, and you can check anyone. Thumb to little finger, pinch, flex the wrist. If a cord pops up in the center, you have it. If nothing appears, you're one of the people born without it. Go ahead and check your other hand too, because here's something people rarely expect. You can have it on one arm and not the other. The two sides are decided independently. Now, how common is missing? This is where the palmaris longus does something almost no other muscle does. Its absence rate is wildly, spectacularly variable, so much so that it's considered one of the most variable muscles in the entire human body. The number you'll see quoted most often in anatomy textbooks is around 15%. The figure goes back to a study by Ryman and colleagues in 1944, and researchers have been poking holes in it as a global average ever since. Because when you actually measure different populations, the range is enormous. Reviews of the literature put it anywhere from about 1.5% to nearly 64% absent. In many European descended groups, roughly a quarter of people lack it. In East Asian populations, it can be as low as around 4 or 5%. In several African populations, it's rarer still to be missing. Studies in places like Zimbabwe have found absence rates near 1.5%. At the other extreme, one Turkish study reported almost 64%. Sit with that for a second. There is no single honest answer to how many people are missing this muscle. It depends entirely on who you ask and where they're from, which raises the obvious question: what is this thing even doing, and why does it matter so little whether you have it? On paper, the palmaris longus has a job. It's a wrist flexor. When it contracts, it helps bend your wrist forward, and it tightens that sheet of tissue in your palm. The problem is that it is terrible at its job, or rather, it's redundant at it, because you have other muscles that flex the wrist, and they're bigger, stronger, and better positioned to do it. Two of them, the flexor carpi radialis and the flexor carpi ulnaris, sit on either side and do the real work. The palmaris longus is the weak, skinny one in the middle that nobody needs. And we can test this directly. If the palmaris longus mattered, the people missing it should be at some disadvantage. So researchers measured them. Multiple studies have compared grip strength between people who have the muscle and people who don't. The result is consistent. The presence or absence of the palmaris longus has no effect on grip strength. None that shows up in the measurements. The picture on fine pinching is a little less clean. A few studies have found very small differences in pinch strength involving the fourth and fifth fingers when the muscle is absent. Others found nothing. If there's an effect there at all, it is tiny, small enough that the people who have it and the people who don't cannot tell which group they're in without doing the wrist test. So this is the situation. You have a muscle that duplicates a job other muscles already do better, that is so weak its complete absence doesn't measurably change your grip, and that a large slice of humanity was simply born without and never missed. That is not what a useful body part looks like. So why is it there at all? To answer that, you have to stop looking at your own arm and start looking at the arms of animals that still live the way our ancestors used to. Here's the pattern that cracks it open. Across the primates, the palmaris longus is not random. It tracks a way of life. Specifically, it tracks how much an animal uses its arms to move through trees. In primates that spend their lives climbing, hanging, and swinging from branch to branch, this muscle is strong and reliably present. In the more arboreal, primates, lemurs, and their relatives, animals whose whole body weight regularly hangs from their hands, the palmaris longus, is a dependable, well-developed muscle. It helps flex the wrist and tension the hand during the constant gripping that life in the canopy demands. Now watch what happens as you move toward the great apes and toward the ground. In orangutans, the most tree-bound of the great apes, with the longest arms and a life spent moving hand over hand through the canopy, the palmaris longus is present in essentially every specimen examined. In one study, all 26 orangutan arms checked had it. In chimpanzees, who split their time between the trees and the ground, it starts to falter. Roughly 1 in 5 is missing it in at least one arm. And in gorillas, the most ground-dwelling of the great apes, it's the least reliable of all. In one sample, 15 of 21 gorillas were missing this muscle in one or both forearms. Do you see the gradient? The more an animal's arms come down out of the trees and onto the ground, the less dependable this muscle becomes. And humans sit at the far end of that line. Our ancestors came down from the trees. We stopped using our arms to carry our body weight through a canopy. We stand and walk on our legs, and our hands were freed for other things entirely. A muscle whose main value was helping a forearm grip and hang from branches suddenly had nothing important to do. So the palmaris longus is, in a real sense, a handhold left over from a life in the trees that our species stopped living. The equipment is still on the shelf. The job it was built for is gone. But there's a deeper and stranger layer to this, and it explains that bizarre, all over the map absence rate we started with. Think about what it takes to keep a body part reliable across a whole species. You need selection, actively maintaining it. If the individuals missing the part do worse, survive less, reproduce less, then the versions of our genes that reliably build the part get passed on and the part stays. That's selection, keeping the lights on. Now take that pressure away. Suppose it genuinely doesn't matter whether you have the muscle or not. The people with it do fine, the people without it do exactly as fine. Nothing is rewarding having it, and nothing is punishing missing it. When that happens, biologists have a word for what the trait starts doing. It drifts. With no selection steering it, the gene variants that build the muscle and the variants that skip it are free to wander in frequency purely by chance, and they wander differently in different populations that have been separated for a long time. Nobody is choosing, nothing is being optimized, the trait is just let go. And that is exactly what a drifting trait looks like from the outside. It looks like a feature whose present or absent rate is high in one population, low in another, wildly different from place to place, with no consistent advantage to either state. It looks, in other words, precisely like the palmaris longus. A 2015 analysis made this case, directly arguing that in the African apes and in humans, released from its old role in climbing, the palmaris longus may be evolving non-adaptively, which is the technical way of saying evolution isn't shaping this muscle anymore. It isn't carefully removing it, and it isn't carefully keeping it. It has simply stopped paying attention. That's why the honest headline isn't, "We are losing this muscle." It's something quieter and odder. Nobody is steering it at all. It's a part our biology has forgotten it's holding. Now I want to be careful here, because this is the point where a video like this usually overreaches. It would be satisfying to say the palmaris longus is useless, it's disappearing, evolution is deleting it in real time, but that's sloppy. And a few things genuinely complicate it. First, vestigial does not mean useless, and it does not mean gone. In biology, vestigial means reduced from an ancestral function, a structure that's lost most or all of the job it originally evolved for. That's the honest claim here. It is not the claim that the muscle does literally nothing in every single person, or that it's vanishing before our eyes. It's variable, not fading. Second, the small functional questions aren't fully closed. Those minor pinch strength findings, a possible role in tensioning the tissue of the palm, small assist to the thumb, these are debated, not dismissed. Barely useful is a fair description. Provably useless in all respects would be going too far. Third, and this is the part I love, humans took this so-called leftover and gave it a brand new job it never evolved for. Because the palmaris longus is expendable, long, superficial, and easy to reach, it has become the single most popular tendon in reconstructive surgery. Surgeons harvest it and use it to rebuild damaged tendons and ligaments all over the body, including the elbow ligament reconstruction that keeps injured throwing athletes in the game. You lose nothing by giving it up, and it can repair something you genuinely miss. A spare part, quietly repurposed. Evolution didn't plan that, we did. And finally, be skeptical of the exact numbers, including the ones I gave you. The simple wrist test misses some cases, definitions differ between studies, and populations vary. The broad pattern is solid, the precise percentages are noisy, so the honest state of play is this. The palmaris longus is a genuinely reduced, functionally minor, wildly variable muscle, a leftover from an arboreal past, and whether it's under pure drift or some faint lingering selection is still argued in the literature. That uncertainty is real, and it's part of the story. We like to imagine our bodies as finished things, designed, complete, every part earning its place. The muscle in your wrist or the empty space where it isn't is a small, quiet correction to that idea. Evolution is not an engineer clearing out the old equipment. It's more like a house that's been lived in for a very long time, by generations who kept renovating around whatever the last ones left behind. Nobody removed the old handholds bolted to the wall from back when this was a climbing frame. They're just there, painted over, still attached, costing nothing, so nobody bothered. The palmaris longus is one of those handholds. A grip your ancestors used to swing through a world of branches, kept on in your forearm long after the branches were gone, and now, in some of you, quietly not kept at all. So go on, touch your thumb to your little finger and bend your wrist one more time. Whether a cord jumps up or two or nothing at all, you're looking at a leftover from the trees. And your body stopped keeping track of it a long time ago.